So let's say you have an equation that is y is greater than 3x plus 2. And then I have another equation that is y is less than 1 half x minus 3. And I want to graph both of these equations, and then I want to shade the appropriate part. So where I shade and where they overlap in the shading is going to be where I can have an x and a y, and it'll make both of these statements true. And that's what I'm mainly going to be interested in. So to do that, basically, I'm going to graph this equation right here uh, by making it kind of like this. If I have y equals 3x plus 2. And what this will do is, this is just a regular line that we're kind of used to. And we'll worry about this inequality later. But let's just say we have a graph, and I'll put it right here. And I want to make this 2 right here. That's going to be where I go up 1, and then I go up 2. So right here is going to be my first dot for this equation right here. So I have one dot right there. And then I'm going to have the slope. And the slope is a 3. So if I go up 3 and right 1, I'll be on the same line. So let's put that down. The 3 right here would be the slope of the line. Slope equals, it's going to be a 3 over 1. And that means I go up 3 and then right 1 from this, the y-intercept right here. So let's go up 3. So I'm at 2 right here. So up here would be 3, and then I'll have 4, and I'll have 5. So if I go up 3, I'm going to go up 1, 2, 3. So now I'm at the 5 mark right here, and then I'm going to go to the right 1. So if I go to the right 1, I'll have x right here is 1. And where those 2 points meet will be where this next dot's going to go. So I'll just follow the x up, and then follow this to the right. And here's my next dot. So let's put that dot down right here. So what I'm going to do now is I'm just going to connect these dots, because this is part of this line right here. So I'll just connect the dots like that, and this will just continue going all the way down like that. So there's my line. So I took this equation right here, made it look just like this, and then there's my line. Now I can get rid of this part over here, and I'll just worry about how do I graph this now for the shading part. So to do that, what I'm going to do is I'm going to get a test point. I'm going to pick an area on this graph. It can be over here, or it can be over here. I'm not sure where I got a shade. So what I'm going to do is I'm going to basically pick a point, and I like picking this right here, 0, 0, because at this point, this is where the x and the y are both 0. This will be 0, 0. And this point up here, just for reference, so that you kind of familiar with doing these points, the point right here, this red point, this would be the 1, 5 position right here. So if you can understand why this is 1, 5, you should understand why this is 0, 0. And this refers to this point right here, and this refers to that red point right there. So back to figuring out where we're going to shade. I'm going to take this 0, 0, and I'm going to plug it in for this. So this is the x, this is the y. Just like this is the x, and this is the y. So I'll have y is going to be 0, so I'll put 0. And I ignore this for right now. We're just worried about this equation right here. Just concerned about that. So 0 is for y, that's what I have here. Then I have a greater than 3 times x is also going to be 0, so I got a 0 there. And then I'm going to have plus 2. Now just solve this out now. 0 is going to be greater than 3 times 0 is 0, so this just goes away. That's why I kind of picked this right here, so this would just go away, I don't have to deal with it. And then I got plus 2, so I have a 2 left over. And now I'm going to say, is this true? Does this statement make sense? Is 0 greater than 2? And no, it's not. So this line would have to be, I have to shade somewhere over here. So all of this would be shaded. And actually, I should have made this a dotted line. So let me go and fix that right now. This should be technically a dotted line because the equation has this right here, where it's greater than, it's not greater than or equal to. This would be a solid line, and this right here would be a dashed line. And it's like this, so let's make it dashed. So I shade it on this side of the line. So that means I can pick a point, any point that's over and on this side of the line right here, and it should make this statement true. So let's check that. Let's see if that really is true. So I'll pick a point that's going to be way over here on this side. So we got looks like we probably have like a -1 over here, and then -2, and then we probably have like a -3, and over here we probably got like a -4. So that seems like it's far enough. So let's say we'll have the x value be -4. So I'll take this and I'll plug it in here. Now we got to get a point for y. So if we picked, let's pick 3. So I'm going to pick this point 3 to go over here, and then I'll pick this point -4 for x. So according to this graph, this point should make sense. So this is just a random point that I picked. You could have picked it for your test point if you wanted to, but I just like using 0, 0. So let's put this test point into this equation. It should make it true because this is where we shaded. We shaded on this side of the line. So let's go back to this equation. This is going to be, this position is -4 for x, and it's going to be a comma 3 for the y. So this is my x value, this is my y value. So let's plug those numbers into here. The y is going to be a 3, so I'll put a 3 down. 3, then I have a greater than, and I have a 3 right here, and then my x is going to be a -4. So I'll put that down. Then I got a plus 2. So I put these numbers into this equation right here. Those numbers in there. That's all I did. So let's see if this statement is true. We have 3 over here, and that's going to be greater than, we have -4 times 3. That's going to be a -12, and then we have a plus 2. So we're going to have 3 is greater than -12 plus 2 will be a -10. Is this statement true? 3 is greater than -10. Yes, it is true, and it makes sense that it's true because this point is on this side of the graph where we shade it. We want to include this point. That's why we shaded up here. I didn't want to shade down here because this 0, 0 made this not true. So all of these numbers have got to be wrong. It's just kind of a process of elimination. You're either going to shade this side or you're going to shade this side. I know I didn't have to shade this side, so I must have to shade this side. So that's how you do this graph right here. Now let's move on to the next one. So the next one, we have y is less than 1/2 x minus 3. Now to do that, I'm just going to make my equation equal to, just like I did before, and I'll graph it the same way, and I'll erase this point over here. This was just so you understood why we shaded on this side of the line. So let's do this one now. So what I'm going to do is my intercept is going to be at -3. So I'll go down -1, -2, and then I have at -3. So here's my next point. So I'll make that blue. Here's my point for this line right here, and this -3 is this 3 right here. That's what that is. So now we have the slope, and the slope's going to be a 1/2, and it's a positive 1/2. So that means I'm going to go up 1 and then right 2. So let's go up 1. We're here, and then we'll go up. We'll go to the right 2. So I'm going to go 1 and then 2. So my next point will be right here where this is 2. So let's see where that takes us. So we got up 1 and then right 2. So we are going to be up 1, right 2. We're going to be right there. So let's make a point right here. Okay, so now that we got both of these points, let's make a line that goes right through them. So here's going to be my line, and I should have made this a dotted line because this is less than, and it's not less than or equal to. So let's make that dotted, or dashed, or however you'd like to say it. And so now we got to figure out where are we going to shade. Now to figure out where we're going to shade, we have to get a test point again. So I'll make a test point, and I'll like to use 0, 0. So let's put in the 0 for the x and the 0 for the y. So the y right here will be 0. And that's going to be less than 1/2 times x. X is 0, so I'll put my 0 down. And then we have minus 3. So we'll have 0 is less than 1/2 times 0 is 0. So all of this goes away. That's why I like using this point. So now we'll have that minus 3. Is that statement true? Is 0 less than negative 3? And the answer to that would be no. No, that's not true. 0 is more than negative 3. So I'm going to shade. I want to shade this way, where I do not include this point, because this point, if I include it into this equation, makes that statement wrong. So I'm going to shade this way. So I'm shading all of that. Now, where are these going to overlap? So these will overlap kind of over here. So if we want to bring out a graphing calculator, we can see exactly what this is going to look like. So let's get a graphing calculator, and we'll type this in. So here's our graphing calculator, and we said we had y is greater than 3x, and we had plus 2. So that was our first graph right there. Now the next one was it was y is less than 1/2 of x minus 3. So this was our next graph right there. And let's see. So this is kind of like what we had over here. We have this 2 right here where it crosses, and that 2 is kind of like this 2 right here. And we had the negative 3, and the negative 3, I get this just right. Yep, crosses it right here. That was that negative 3 point. And we shade it kind of down for that one. So it's kind of, what we have over there. And this is what the calculator gives us. So where they cross is right in this area. So basically we can take numbers in this area right in here, and we can plug these numbers in for both of those equations, and it'll make both of them true. The area in the green over here, this area, all the green would make only one of the equations true, and then this kind of orange color over here would make all the equations true for it. If we plug in these x and y numbers that are in here. But if we plug in here in this area, this would make both of them true. So we're going to be interested in this area right in here is what we kind of want right there.